Let's learn how to count. So we have a 3-digit number that is made up using 3 randomly selected digits from 0 to 9. No digit may be repeated. And 11.3.1 is saying, let's determine the total number of possible 3-digit numbers greater than 100 that can be formed. So we have 3 spaces to fill because it is a 3-digit number. We need all possible combinations that are greater than 100. So what does that restriction greater than 100 tell us? It tells us that 0 cannot occupy the first position. If 1 occupies the first position up to 9, then it is okay. That digit will be greater than 100 because repetition is not allowed. So how many possible numbers can occupy the first spot? 9 possible digits can occupy the first spot. 1 up to 9. 0 cannot occupy that spot. So now that out of our 10 digits from 0 to 9, we've exhausted 1. So how many digits can occupy the second spot? 9 digits can occupy the second spot because out of the 10 we have only exhausted 1 when we occupied the first spot, and then on the third spot 8 digits can possibly occupy that third spot because we don't have any special restriction. This will give you 648 possible 3-digit numbers that are greater than 100. Let's look at 11.3.2. Determine the total number of possible 3-digit numbers, both even and greater than 600, that can be formed. So we need all possible 3-digit numbers that are greater than 600 and are even. So let's break that down. What does greater than 600 implies? It implies that on the first position we can only have 6, 7, 8, or 9, because if a number starts with 6 and no repetition is allowed, then it will be greater than 600 because we cannot have 2 zeros. So if it starts with 6, 7, 8, and 9, we don't have any issues. And what does it imply when we say that the 3-digit number must be even? Think about this. 403. It is an odd number. Why is it an odd number? Because it ends with the odd digit. So for a number to be even, it just needs to end with an even digit. Nothing else matters. That is why 902 is even. It starts with an odd number, but then just because it ends with an even number, the entire number becomes even. So we need an even number to occupy this very last spot. And here on the first spot, we need a number which is 6 or greater than 6. But there's a conflict of interest. So on the first spot, we can occupy that spot with either 6, 7, 8, or 9. These are the numbers that can occupy the first spot. And then on the last spot, we can occupy that with 0, 2, 4, 6, 8. Even numbers. But I want you to realize something. 6 and 8 can occupy the first spot, but then they can also occupy the last spot because they are even. So we have to break down our problem into 2 in the following way. So let's say that the numbers that can occupy the first spot are odd. Let's make that as assumption first. Well, in probability, we don't make any assumptions, but then we're going to account for that assumption. Let's just make it for the time being. So let's say out of 6, 7, 8, and 9, the odd numbers are going to occupy the first spot. So we have 2 odd numbers, which are 7 and 9. 6 and 8 are even. So we've occupied the first spot with either 7 or 9. And now let's come to the last spot. We need the last spot to be occupied by an even number. Well, if the first spot we assuming that is getting occupied by either 7 or 9, then we still have our 5 even numbers that are intact that can possibly occupy the last spot. So we have 5 right there. So out of 10 digits that we have used the 2, so we are left with 8. This is the possible ways if either 7 or 9 occupies the first spot. But we also know that 6 and 8 can occupy that first spot. So let's go ahead and calculate the total number of possible ways when that is the case. So 6 and 8, it's only 2 digits, right? So we have 2 digits that are fighting for that first spot multiplied by, so we have 5 even numbers. We're saying that one of them is going to occupy the first spot. So on the last spot, we are only left with 4 even numbers. So we're going to have 4 right there. And just like what we did here on the first part of our solution, we have exhausted 2 digits. We are left with 8. So 8 will get in there. And the answer I'm getting here is 144.